So what I want to discuss today is a little bit the vision on how we see the design to manufacturing part. Partnerships are incredibly important to us, but also the pressing need to simplify those AM workflows. Now, I do want to start a little bit with the vision on how Materialise see this evolving, because this is just the beginning. We believe in a future where the boundaries of production are actually no longer defined by trade-offs between flexibility or volume. We want to make sure that all these innovative ideas can be translated to designs using nTop, of course, and where those designs can be produced by thousands and millions using Magix preferred workflows. But we do see a future where that journey is a straight path, so that a single user can go from design to manufacturing using end-to-end solutions, an end-to-end workflow without any conversion, without losing any traceability. Now, this also empowers sectors, specific applications for aerospace, healthcare, energy, for example, and we see an unprecedented level of precision and also personalization. And with that, we have a serious increased complexity of the parts as well. We also see the need for a new level of automation, and also this will unlock a lot of new applications, and that's a little bit where I want to head towards today. Now, this is all good and well in theory, but it's really hard to do. Convincing to use AM in scale is something that we call the shift from why use additive manufacturing on really how to use additive manufacturing. And what we see when talking to all of you, our customers, and also a survey that we have done across the world, is that a lot of companies are struggling with the perceived complexity of those designs, making sure that they are printable, but making sure that it's repeatable as well. What we also see is that the cost outlay of those parts, those advanced parts, are extremely expensive. And on the other hand, integrations is something that we're struggling with on a daily basis. So what we need to do is solve all these items, and if you're in medical or in aerospace, regulations are also a big part of it, of course, that you have to take into account. So that being said, what we need to do is make sure that we can prepare ourselves on an end-to-end workflow. Now, an end-to-end workflow simplifies the process, and CO-AM is something that certainly can help with that. Now, Magix is part of the CO-AM platform. So Magix is an application on CO-AM, and this is something that can help you connect those dots from design to the full manufacturing part. Software can remove those barriers to make sure that we can drive that adoption at scale. Now, this is something that we can't do ourselves. Like, collaboration is key. What we're now seeing in today's 3D additive manufacturing industry is that we have a myriad of platforms, that we have a lot of interfaces, operating systems, cloud computing environments. We have all these different topics that come together. And this diversity is great. This offers you a lot of tools at your disposal, but it's really difficult to make an end-to-end solution out of this. And introduce complexity in your process, but also need to increase the costs. Now, this is something that you have to be cautious about. If you have all these different topics, all these different solutions that need to work together, how are you going to make sure that this is repeatable, that it's traceable, and that it's also scalable within your company as well? Now, this is something that we call the collaboration catalyst. The collaboration catalyst, from our point of view, is something that we can't do ourselves. The design to manufacturing workflow is not something that Materialise can solve by itself. It's not something that nTop can solve by itself, but it's really something that we really want to drive as a company, making sure that we achieve this as a greater vision. We want to go beyond our own individual interest and making sure that we can push all those workflows scalable across the industry. We're already a very small part of the total manufacturing landscape, let alone that we're being operating in silos right now. So this kind of collaborations with nTop and Materialise, we see this as really a catalyst for growth. Now, CO-AM, as I said earlier, is something that will facilitate this. This is really something that connects all the third parties together in the Materialise ecosystem. And today I'm here, of course, to highlight one, and this is the nTop partnership. Now, with the nTop partnership, we have a direct Magix integration. So that means that we integrate now the kernel, the technology of nTop directly in Magix. So what does this mean? And this is something that I will highlight based on use case. of Wärtsilä. You see the part there. This is a miniature version of the part, and I do believe, I haven't seen Brute SLM yet, but the big part is there as well. We always solve these cases based on problem statements of our customers, based on what you give us as input. And Wärtsilä is one. So Wärtsilä is a creator of maritime and energy components. In this case, this is a diesel engine. And what you see there is a cylinder head that consists out of more than 10 moving parts. So what I wanted to do is basically simplify and also optimize that cylinder head, the design of the cylinder heads. But as you all are using nTop and Magics as well, they run into the limitations, of course. So what we have seen is that that part that has been optimized, and we'll show the workflow later, it has been here on the repeat already, was not printable with current solutions on the market. So those current solutions, in this case of Wärtsilä, they were using nTop and Materialise. So the bottleneck really there was meshing. So they had this fancy, complex design that they had created in nTop, but meshing it took over many, many hours, let's say it like this. But importing in Magics was near impossible. It took days. And we're not talking about slicing bending. Slicing was just impossible. As you're nodding, you know for sure what I'm talking about. So now we sat down together and we said, how can we solve this? They had this awesome new thing called the nTop kernel. We had a problem statement that we needed to solve. So we said, let's work together, let's solve this together. And we had this nice collaboration between nTop and Materialise, making sure that you can have that end-to-end design to manufacturing workflow. Now, how does it look like? Because it's really interesting to see. And this is not sped up. This is really nice to see, except the slicing part, I took that out. Otherwise, it will take too long. But here we see the part being designed in nTop. And the increased complexity when it comes down to all the possibilities that nTop offers you. So you see there the creation of the gyros for the heat dissipation. You have these nice internal cooling channels that are in there. Now, to export this from nTop, this took hours. I don't know exactly how many hours it took. It was near impossible. We gave up at a certain point in time just for the benchmarking purposes. But what you see here, exporting natively the .implicit file took only 19 seconds. And here you see live the import part in Magics, natively implicit in Magics itself. And here this is really nice to see. You can actually set your rendering properties. So what you see here, you import the part itself in Magics, and you already have a full part in Magics itself. What you see here is actually the rendering being done. We offer a low polygon way of working, and the rendering is being done in the background. So you already can use Magics on the fly with the full part and do all your work. Now, we enable almost full build-up capabilities in Magics. So here you see, for example, labeling on the implicit part itself, where you can actually start doing all the things needed on the implicit parts. Again, this is live, this is not being sped up, this is just as it goes. You apply this, then you can step further, you can inspect everything. And again, this is being done on the .implicit file. After this, you can do your support generation. Now, with support generation here, you can see there, you can code everything as well, but you can actually really make sure that everything is disconnected from each other, and also do your print analysis. And this is really something important. So you can check your Z height, you can do your measurements, you can check your gyros, you can do your thin wall analysis and so on. So this is all based on the functionality of Magics. Again, this is on the fly, not sped up. And afterwards, when you go to the printing stage, you can create a composed part out of this, and we'll definitely come back to that later, because the composed part is really something that is for us extremely important. It's making sure that you can combine all your technologies or all your geometries that you're using to create your part and create it in one manufacturable part. How many you need doesn't matter, you can just copy them, create virtual copies. You don't have to add all these parts separately. Again, do the checks, and then go to speed. Now, this entire workflow went from unprintable to import in 19 seconds, actionable in Magics in under a minute, and sliced in a matter of hours. So it went from an unprintable part to a sliced part in a matter of hours. And this is also by the power of the new next-gen build processor that we now have. So with the next-gen build processor, we also support fully the nTop kernel. And then you can slice also without converting to a mesh natively on the implicit level. You can set your strategies based on every part. So if you want to have build strategies on a different level, that's also possible. And you can afterwards, after it's been sliced, you can definitely check on slice level via inspector if you want to see are my gyros connecting well, is everything going well, are my walls loose or not. So this is a very powerful end-to-end workflow based on Magix and nTop. Now, this is a use case, the part is over there, you can definitely check it out. But this is not the end. So what I said is the composed part is really important. And for people that already know Magix for a long time, we have done quite some route and took some journey. So everything in Magix 26 was mesh only. So this is where the problem started. nTop challenged us many times here, like clean up your meshes and then that was the other stuff like this. So we heard all of you. As of Magix 26, we introduced the UF functionality with a partnership with Siemens. And with Magix 28, what we're now doing is an early validation program. So any of you wanting to get your hands on this, we have a Magix 28 version that is nTop capable, that's capable of printing those implicit files. And later on, what we're now pushing towards Magix, our next release, with the beta coming out on February 14th, release May 25th or 15th, and we do composed parts. So what we're doing there, and that's really awesome, we're pushing all those technologies onto the build platform. So it doesn't matter if you're working in mesh, on BREP, implicit, support generation, or whatever that you're using, you will now be able in Magix 29 to use all those geometries natively on build prep to do your build preparation. And afterwards, slice in the native format as you go. So you slice your meshes natively in meshes, you slice your implicits natively implicits, and you can make a composed part made out of outer hull, the implicits, supports, and so on. And this is really the power of this collaboration, is having those manufacturable parts, being able to design, import in Magix, do your data, build prep, and slice, all natively end-to-end. So this is how the workflow looks like. If you have any questions, let me know. We do have an early validation program that we're starting up February 14th. So if you're interested, leave your notes, leave your contacts, and then we can definitely get you in contact with us and give you a better release. That's it. If you have any questions, feel free.